So for this week's design quiz, there were two problems you had to complete. The first one was to build the pyramid of cookies, and the second one was the function that would sink solid blobs past all of the bubbles. So we're going to look at the solutions for both of these problems, and the first criteria we're going to look for is commit ready. So this is the same as back in part 1. We just want to check that there's no code left behind that's commented out other than possible stubs and templates, and that the file is neat and tidy with no scratch work. So we'll take a quick look through here. This is everything we were given. Here is our solution to problem 1, and it looks like everything is in place. Nothing's left behind. Here's problem 2, and it looks good as well. So I think we can give this a good for commit ready. So the second criteria we're going to look at is design completeness. So we want to make sure that the design has all design elements, specifically those from HTDF, and that they're all well formed. So we'll look through the file. In our first function here, we have signature, purpose, check, expect, stub, and a function body. In this second one, it looks like we've forgotten a stub, so that's one element that is missing, but the rest of that looks good. And in our solution to problem 2, we have stubs, check, expect, signatures, purpose, function bodies. All our helper functions also have that, and it looks pretty good. So we're missing one stub, everything else looks great, so that's one mark off, and we'll give this a fair for design completeness. So the next criteria we want to look at is internal quality. And for this design quiz, we're focusing specifically on the internal quality of the elements of the file that have to do with natural numbers or helper rules, because that was the content from this week. So if we look through our file, this first question is on natural numbers. So we want to make sure that we're using the correct template from naturals, and we want to make sure that if there's any necessary helper functions that we have used those. So looking through here, we were definitely using the template for natural numbers. We have two con cases. We check if it's 0, which is the base case, and otherwise we have a recursive definition. So this looks great. If it is 0, we just produce the empty image, which is exactly what our check expect shows us. Otherwise, we want to put a pyramid of size 1 smaller above a row of size n. So this is a helper function we've designed. So let's look at the design of that. So we already noticed we were missing the stub, but other than that, all of the correct design elements are here. And if we look, this again definitely is using the template for natural numbers. We have a correct base case, and here's our recursive case. So we're making a row by putting one image beside a row of one smaller. So this looks like it'll work, and we can run the file. All 22 tests passed, so that looks great. So now we want to look at our blob problem. In this problem, we really need to pay attention to the helper rules. So we can look at our solution. So this is the function that we started with. It checks if the list is empty, in which case it produces empty, and otherwise it's calling a helper function that consumes the first of the list and the rest of the list having already been through the recursive call. So this is very similar to the sort strings or images function you would have seen in the videos and lecture questions. So once we've called the recursive function on the rest of LOB, we can assume that all of the blobs have been sunk, and now we just need a function that sinks the first blob into the list of the rest. So we can go look at this function. So it goes from list of blob to list of blob. That's not quite right. They forgot that it's consuming a second argument, so we'll add that in. But now if we look at it, it checks if the list is empty, in which case it just makes a list of the single blob, which is great. Otherwise, it asks another helper function here to check if the blob is solid. If it is, it sinks the blob 1, and otherwise it just adds it to the top of the list. So that looks great, looks well formed. We just need to check this last helper function here. So it goes from blob to Boolean, produces true if the blob is solid. That looks great. It's well formed and clearly produces the right result. So this was a great solution. We just had that one problem with the signature, but seeing as we're focusing on the natural numbers and the helper rules, we could give this an excellent for internal quality, or if we're being picky, we could take off a mark for that signature and give it a good. But either way, it's a great solution. So our final criteria is, does the design satisfy the problem requirements? And this design definitely does. It only had a couple tiny errors, and it followed all of the helper rules. and both the pyramid function and the sync blob function do exactly what was asked of them. So we can give this a good for satisfies the problem requirements, and this was a great solution. Now you're ready to assess your own work. Your solution might not look exactly like ours, but do make sure that you have followed all the helper rules. And if you have any questions, feel free to ask us in the discussion forums.